The binomial theorem of the zeta function can be inversed by the functional equation of the analytic continuation, and the eta function becomes the odd zeta function. That is, Dirichlet lambda function. If the binomial theorem of the zeta function is inversed, the gamma functions of the numerator and denominator of the combination become the zeta function and odd zeta function that are symmetrical to the critical line by the functional equation. Therefore, the odd zeta function can be obtained by the zeta function of the negative domain. In addition, since there is no gamma function, the non-trivial zeros of the odd zeta function can be calculated in GeoGebra, which does not support the gamma function or factorial of complex numbers. The sum of the negative zeta function is divided into two alternating sums by the trigonometric function, and as mentioned in calculating of the non-trivial zeros of the zeta function, the sine and cosine become equal at the critical line of s equals 1/2 plus ai, so it can be transited to another zeta function or eta function. The blue odd zeta function is 1/2 of sum of the alternating sum up to 70 terms of the zeta function and shows an error of more than 6 decimal places with the red odd zeta function by the mathematical function. The error of the odd zeta function of the first s equals 1/2 plus 0. I is more than 10 decimal places. This is the same range as the error of the eta function by the alternating sum of more than 10 million terms, and the error becomes significantly less when the terms of zeta function are increased. The non-trivial zeros of the odd zeta function are the same as the non-trivial zeros of the zeta function and eta function, but they pass through the zeros through different paths. There are 13 non-trivial zeros in the range where the imaginary part A is less than 60.